photoresistors and a servo motor to simulate how a solar tracker works. The ideal is that, depending on the difference in light between the two photoresistances, the servo will rotate to one side or the other. A small object was also added to act as the solar panel, so its movement could be seen. If both sensors receive the same amount of light, or if it's dark like at night, the servo will stop and stay at 10 degrees. Facing sound, the angle of the panel must be shown in lab view along with the light's value from the both photoresistors. Also, the angle, date, and time will save in a text file. On the front panel of LabVIEW program, a control was added to select the serial port used to connect the Arduino. Two numeric indications were also added. One showed the servo angle and another to show the difference between the two photoresistors value. A control was also added to change the speed to the program loops. Two bars graph were included to visually show how much light each photoresistor receives. At the bottoms, there are three buttons. One to start the program, one to save the data, and one to stop the simulation. Save the data and stop the simulation. In the diagram block, blocks for Arduino connection are included, as well as blocks to read data from the photoresistors, which are connected to the pin 3 and 0 of the Arduino. Each reading is passed through to convert it to turn it into an integer number, which is the shown in the bar graph, this part. To move the servo motor arc and compare the sensor values, a case structure was used. The case selector is connected to a logical OR gate, which is connected to the start button and also has feedback loop with a false constant. This creates a lock system that avoids error when they're running the program. The values for the photoresistors are subtracted from each other and compared using different greater than and less than condition. If the difference is very small, less than 1, the servo moves to 10 degrees. Like the instruction said, if the difference is between 1 and 53, a combined comparison decides the servo direction, based on which photoresistor was more light. This makes the panel follow the sound. The control the servo motor movement, the signal PWM needs to convert into position value. In this case, 610 is equal to 10 degrees and 2388 it's equal about 110 degrees. The servo moves based on the light difference and compression make sure it doesn't go below 10 degrees or above 110 degrees. This comparison we need if style selector and a formula that adjusting the results to show the correct angle. To move the servo, each position is passed to a block controller. A timer is also added and connected to a numeric control. The link's loop frequency block is used to show the frequency and shows the loops run. At the end of blocks are placed on the right side of the program to turn off the servo and disconnect the Arduino when the the simulations end. If the start button is off, the program doesn't nothing. It just kept connection but doesn't run any process. To save the data, another case structure is connected to a save button. When to save a button is true, the following blocks are used. Outside the main structure, a new file is created using a build path where two constants are added, one for the file locations and one for the file name. Then the delete block is used in case an old file already exists. After that, the open create reprise file block is used to open the file in write-only mode. Inside the main structure, the write the text file is used to write inside the file. The data and time are added using the date time block, and everything is shown in using concatenate strings. The numbers are turned into text using number to fractional string, and some text is added to keep it in organized. A carriage return is block is used to move to the next line. Outside of the block, to finish the text file, a close file block is added, which ends the writing process. If the save button is off, or in the false case, and the structure just connect inputs to outputs without doing anything. For the loop condition, give me a minute. An OR logic gate is used between the exit stop button and the error output of the main blocks.
For the operation of the experiment, two photoresistors and a servo motor were connected to the Arduino. The servo motor simulates a solar panel which changes its position as the light moved.